let's discuss about modulus, argument, and what is conjugate. Let a complex number, let's say z equals to a plus ib. Remember what is a and b? A and b are what? Real number. Okay. Let's consider in complex plane. Now here what we have? Here this is what? X-axis and this is y-axis. And this is called real axis this way, and here this is imaginary axis in this y. Now z equals to a plus ib denotes a single point in the complex plane, meaning here let's consider this is a, from here to here a, and from here to here b. Okay, let's consider a comma b. Okay, now this point, okay, this point a comma b is denoted by z equals to a plus ib. Okay, if it is given that z equals to a plus ib, then what is its point? Okay, now its point is what? Its point is what? A comma b. Okay, now if z equals to, for example, z1 equals to 2 minus 3i, then what is its point? Okay, its particular point in complex plane is what? Point is 2 comma minus 3. Similarly, if you have z2 equals to 4 plus 5i, then its point in the complex plane is what? 4 comma 5. Okay. So for every number, for example z1, you have specific points in this. We have first quadrant, second quadrant, third quadrant, and fourth quadrant. All points, whatever it is given, for example, if I have z equals to 1000 plus 90i. Okay, here the point is what? 1000 comma 90. Here 1000 goes in this direction and 90 goes in this direction. Here you will get some points. Okay, whenever you have complex number, it is a point in the complex plane. Okay, now this is origin. Okay, so if I join like this from here to here, okay, now if I want to find distance between O and, say for example, A, okay, this is O and A, remember we have 2 points. If we have 2 points for x1 y1 and x2 y2 a b, the distance between these two is given by AB distance is given by square root of x2 minus x1 whole square plus y2 minus y1 the whole square. Okay, the distance between AB, this distance between AB is given by this. Similarly, origin is what? We have 0 comma 0. Now if you want to find distance between these two, we call that is called modulus. Okay, so modulus is what? Is the distance from origin. For every points you can find modulus of the particular points. Okay, what is modulus? Modulus means what? It's a distance from the origin. Okay, so what is this? So OA, distance of OA is equals to square root of A square, A minus 0 whole square means what? A square plus B square. Okay, this is what? This is the distance from origin. Okay, this is called, we call modulus. Okay, of z. Z is what? A plus ib, or sometimes we denote it by this. Okay, mod of z equals to this. Therefore, for every points over here, so if I have, for example, here 2 comma 3, here 2 comma 3, here 2 has, for example, 2 comma 3, for this 2 comma 3, you can find its modulus by this formula. So if I want to find, for example, if I have z equals to 2, I can express this in the complex form is 2 plus 3i. So mod of z equals to square root of 2 square plus 3 square, that is 2 2s are 4 plus 3 3s are 9 that is square root of 13. Okay, it's a distance from the origin, so we'll have plus over here since distance is positive. So mod of any z, modulus is what? Is always positive, as well as it's a distance from the origin. I already explained what is modulus. See what is conjugate. We have z equals to what? A plus ib. Okay. Any complex number, it is, I can express z equals to a plus ib, where a and b are real number. Conjugate is the image. Okay, the image of this in real axis. We have this is real axis, right? So its image is somewhere like this. Okay, let's consider z bar as its conjugate. So let's consider z bar is equals to, or you can say z bar, the point of z bar will be what? This distance is what? A. This distance is what? B. Okay, now here this real axis is same distance, it's going over here. Okay, same distance. Since it is image, here this what? This will be what? Minus b, right? So this is what? Minus b. Therefore conjugate is what? Conjugate is what? Its image. Conjugate means conjugate of z means its image in real axis. Conjugate of any point is the image of that particular point in real axis. Okay, so therefore z bar I can be written as a minus ib, means you have to change in the imaginary part sign. Okay, for example, if I have, it is the conjugate is denoted by z bar. For example, if z equals to 2 minus 3i, okay, then conjugate of z will be what? Say let's say 2 minus 3i, here 2 comma, the point is what? 2 comma minus 3. Here we have 1 2 2 comma minus 3 is somewhere like this. Okay, now its image will be what? In the real axis, so the image will be in this way. Okay, so this point will go to somewhere like this. Okay, therefore real part will be as it is, but imaginary part will change sign. Here 3i. Okay, so if z is this, then its conjugate is this. Okay. Now if the complex number is this, for example z equals to minus 3i plus 0 or this, then here conjugate of z will be what? Change is minus, change is sign. If it is minus, then plus 3i. Over here also, if it is 3i, then plus 3i. If it is plus, then minus, minus then plus. In the what? In the imaginary part. In the imaginary part, you have to change its sign for conjugates. What is argument? Let's see. Argument is the angle made by this z, okay, to the positive x-axis. So this is the angle made by this z to the positive x-axis. Argument for this complex number is somehow big, so you can see one of the lectures, one of the video, but for time being, for now I will speak very shortly over here. Now from here to here is, the point is what? A comma b. Okay, therefore this from here to here distance is what? A, and from here to here distance is what? B. Since right angle triangle, so OZ, let's see, O, B and Z. So this angle is given by what? Tan of theta is given by B upon A. So B upon A, therefore theta equals to tan inverse mod of B by A. Okay, so this is called arc, ARG, arc of Z, argument of Z. So for time being, just remember what is argument. Argument is what? Angle made by Z into the real axis of this real axis. Okay, here theta is given by this.